Welcome to Mrs. Miller's notes for her pre-calculus class. These are the notes for section 12.4, day 1, entitled Mathematics of Finance. And we're going to spend a couple days on these objectives, but for today, for day 1, we're going to talk about the amount of an annuity. And first thing we have to do is actually talk about what an annuity is. And an annuity is a sum of money that's paid in regular equal payments. And the word annuity comes from annual, so it means yearly payments, but they can be broken down so that there's semi-annually, quarterly, monthly, etc. So payments are usually made at the end of every payment interval, and the amount of an annuity is the sum of all of those individual payments from the time of the first payment until the last payment. Okay, and we're going to calculate interest in there as well. So our final amount is going to be written as A sub F when we're talking about our final annuity. Okay, so this would be something like we have here where we're investing money for an annuity. An annuity can also be payments if you're making payments for a certain item like a car or a mortgage as well. So we're going to take a look at several different types of real world examples here. But here an investor is depositing $400 every December 15th and June 15th. So that's 2 times a year for 10 years. So already that tells us that we've got 20 of these payments that we're making. And he's depositing it into an account that earns interest at a rate of 8% per year. Now, if it's 8% for the whole year, and he's doing this twice a year, that means that it's 4% each time because it's compounded semi-annually. That's our next key phrase there, that it's compounded semi-annually. So how much will be in the account immediately after the last payment? So what we're doing here is we're trying to figure out our final amount. And we're starting with our very first payment, which is $400. And then the next one will be $400 times the interest rate that he gets. Okay, and he's gaining that 4%. When you invest it, you're gaining the interest, so it's going beyond 100. So he's to show that he's growing 4% every time it's calculated semi-annually. We're going to say that he gets 104%. So instead of writing that as 104%, we write it as a decimal. Okay, so this would be his next amount. And then we would add up another $400 times 1.04, but this gets calculated for a second time now, and so on and so on and so on. And this is going to keep happening though until he gets to his very last payment or his very last deposit. So that's going to be 400 times that interest rate. And again, we're doing the 4% because it's 8% for the whole year and he's doing it twice per year. Okay. So that very last payment, remember this is normally n minus 1 and the number of payments he has is 20. So 20 minus 1 is going to be 19. Okay, so this ends up looking a lot like a geometric sum. And what we're multiplying by, our ratio, is the 1.04. Okay, so if we're going to rewrite this in terms of a geometric sum, we can write it so that we've got our final amount, and we're starting with our $400, and then we would have the 1 minus our rate, which is the 1.04, and then we're going to take that to the n power, so that's going to be 20 times, because he's got 20 payments, over the 1 minus our rate, or our ratio. Okay, so instead of actually trying to calculate this out for finding the separate 20 amounts and then adding them up, which is what we were on a path towards here, we can use our summing equation here. Okay, so now it's order of operations. You want to do 1.04 to the 20th, get that decimal, subtract it from 1, divide it by whatever 1 minus 1.04 is, negative 0.04. Okay, so when you simplify that all the way down, you should get 400 times 29.78. So if you got that as you were doing your calculations, that's good. And then when we do our final step of multiplying by the 400, we should get $11,911.23. So remember, on tests and quizzes, when we do these types of problems, you want to write your final answer in a sentence. So how much will be in the account immediately after the last payment? This is how much. Okay. So if he deposits $400 twice a year, every year for 10 years with an 8% interest rate, this is how much he'll have at the end. Okay. So here's a nice graphical way to look at this. Not so much graphical more as it is just a drawing, but the book does a good way to describe this. So here he's got his $400 that he's paying. Here's his years. Okay, and then this is showing how that last payment actually is going to be to the 19th power, and then as it decreases, that very first payment didn't have any interest applied to it yet. So it's really the 1.04 to the 0 power, and then we have the 1.04 to the first, and so on. So that's why our rate is the n minus 1. We had 20 payments, 20 minus 1 is 19. Okay. So you don't have to necessarily do all that. You don't have to draw that out, but that's just a good visual way to think through the problem as well. Okay. And here again, this shows how we're taking that final annuity amount to find that final payment, and we're adding it all up. And this was our sum that we did, and there's our final amount that we got. Okay. So these are the types of problems that we're going to think through here when we're dealing with annuities. And they're really just finding a sum for a certain amount of time. Okay. So a regular annuity payment is called the periodic rent, and that's going to be noted by the capital R. So we're getting close to coming up with an equation here for an actual annuity. So now they're going to introduce these new variables. So we have our periodic rent. Okay, that's our R. And then we're also going to have I for our interest rate. And then we're going to have N for the number of payments. Okay. And now when we're dealing with our interest, we might have to do an extra little step, but I'll explain that as we get through our examples. Sometimes we have to take that interest rate and we have to divide it, like we did in that opening example where we took the 8% and we divided it by 2, so we got the 4%. Okay. And they don't explain that here, but just know that for that interest rate, we might have to do some division to it. And we always assume that the time period in which the interest is compounded is equal to the time between the payments. So it's being compounded over that amount of time. Okay. So this then is the equation that we're going to be working with, okay, in the bottom of the little box here. Okay. And again, the R is going to be that, that rent, okay, or the payment. And then the I is going to be the interest. The N is the number of payments. Okay, and then the A sub F, that's your final amount, the final annuity. Okay, so again, this is going to be on your formula sheet, so you'll have access to it. But let's take a look at a couple examples here where we're actually using it. Okay. So we're going to find the amount of an annuity that consists of 24 monthly payments. So it's monthly, so we have to make sure that we're aware of that key word there. Okay. So it's 24, that's our number of payments already. And we know that it's going to be monthly, so we're going to have to deal with that 12. And the payments are going to be $500 each, so that's that renting amount. That's my R, that's the 500. And we're going to make those payments into an account that pays 8% per year. And again, it's compounded monthly. Okay, so sometimes that phrase might be in the problem. It might say compounded monthly, compounded semi-annually, compounded annually. But it also tells us here that we've got monthly payments. So sometimes that compounded phrase might be in the problem. Sometimes it might just tell you there how many payments you have. But for our I value, we're going to have 8%. And remember, we want to change those percents to decimals. So we're going to scoot it over 2 places. So it's really 0.08. But then we're going to divide it by 12 because it's monthly payments. So 8% is the interest per year, but he gets that over the whole year. And if he's doing these payments every month, we got to take that 8 and divide it by 12. So we're going to get 0.0067 then for our percent every time. Okay? So after we've read through the problem and we've identified those 3 pieces of information, then it's basically just substitution. Okay, so we're going to take our formula. We've got our A sub F, and we're going to start with our 500 for the R, and then we'll have 1 plus, and then we've got our I, 0.0067, and then that's going to be to the 24th power. Oh, and I was thinking that the whole fraction was in the parentheses, but it's just that little part there. So to the 24th power, because we've got 24 monthly payments. Okay, that's our number. And then we'll do minus 1 from there. And then that's all going to be divided by the 0.0067, divided by our interest again. Okay, so now it's going to be plug and chug into your calculator. Do the 1 plus 0.0067. Hopefully you don't have to actually add those in your calculator. Then take the 1.0067 to the 24th power, get an answer. Then subtract 1, get an answer for that. Then divide it by the 0.0067 and get an answer. Now, if you've done that much, you should get to 25.943. So if you get that amount when you simplify down this big fraction, then you're doing it correctly. And then we times by 500 as our last step there. So we'll end up with $12,971.67. And again, you want to write your answer on a quiz or a test as a sentence. So you would say this person will have $12,971.67 after 24 monthly payments of $500. Okay, part B, last example for this section of the notes. Okay, here we want to find out how much money should be invested every month at 6% per year, compounded monthly. That's a key phrase there. So we've got our 6% here for our interest rate. So that's really going to be 0.06, but it's compounded monthly, so I'm going to divide by 12. So that's where I get the 0.005 from. And then we want to have $2,000 in 19 months. So that's my time. The N is the 19 months. That's my number of payments. And we want to have this amount. So it says how much money should be invested. So I don't know my R value here. That's what I'm trying to find. They actually tell me what I want to get out at the end. They're telling me my final amount. So here we're just going to be solving for R instead of solving for A of F. So this is just a little bit trickier solving, but we're still going to substitute. We'll put the 2,000 in for A sub F. I'll leave my R value as R, and then I'll have 1 plus my interest, 0.005, to the 19th power, and then that whole thing will be minus 1 all over 0.005. So now there's a couple different ways that you could solve this. Probably the most straightforward way is to simplify all of this down, this big fraction, and then you can divide it over. Okay? The other way would be to rework this equation so that it's solved for R. and then you can do the calculations, but either way is correct. Okay? So if we take the 1 plus the 0.005, and then we're going to take that to the 19th power, get an answer, and then we'll subtract 1, get an answer for that, and then we'll divide by the 0.005. Okay, we'll have 2,000 equals R times 19.88 if we rounded. And then I'll take 2,000 and I'll divide by that amount. And then for my R value, I'll get 100.61 if I round. So $100.61. Okay. And again, if that's your final answer, then you would say you should invest $100.61 every month in order to have $2,000 at the end. That would be how you would write your answer in a complete sentence. Okay. So take a look at the examples in the book as well. Sometimes they have a little bit different way to solve these, but it's a very short homework assignment, but these are complicated problems to read through and pull out the important information. And sometimes it's a little confusing to try and figure out what information goes where. But remember, for your interest rate, you might have to divide it by how many times you're making those payments in order to get the correct decimal to use in your formula. So practice these problems, and if you have questions, come on in and see me before school.